Hello friends, welcome to my channel Study Corner. So today we are discussing about the difference between the capital G and small g. It's a common for some students to feel confused about this too. So let's address this confidently and get it right. Capital G and small g. Capital G. So it is a universal gravitational constant, while small g, it is a acceleration due to gravity. So if we are discussing about capital G, it is a fundamental constant used in calculating the gravitational force between two masses. Let's say we have a masses m1 and m2. Let's say we have a masses m1 and m2. So to find the gravitational force, capital G is required for that. Further, capital G gravitational constant is a scalar quantity and small g is a vector quantity. If we are discussing about the value of gravitational constant, capital G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. And if we are discussing about the value of small g is 9.8 meter per second square. Its value is a very small, so we cannot feel it. And if we are discussing about the small g, it is a positive for downward falling body and it is negative for upward falling body. That means g is a negative typically means you are working with upward as a positive, and since gravity pulls down, it has a negative value written as minus 9.8 meter per second square. So capital G gravitational constant, it tells us how strong gravity is between two masses in the universe, while small g gravity, if you drop something, its speed increases by 9.8 meter per second every second. Now its value does not change by changing the place. Let's say in a universe, for any planets, the value of capital G gravitational constant is same for all the planets, while for the gravity, its value changes by changing the place. So in general, if we have to remember that small g is a local effect of a gravity on the earth, and capital G, which is a universal rule of how gravity works everywhere in the space. Now we have to prove the relation between the capital G and the small g gravitational constant and gravity. From the figure, let the radius of the earth is capital R and its mass is capital M. Object of mass m is lying on its surface. Force F is equals to mg is applying on the object from the center of the earth according to the Newton's law of gravitation. So the formula of force is equals to gmm upon r square. But here small r is equals to capital R. So F is equals to gmm upon r square, which is the first equation. But F is equals to mg, which is the second equation. By comparing the equation number 1 and equation number 2, we can write like this. gmm upon r square is equals to mg. By cancelling the small m on the both side, the final equation, which is gm upon r square is equals to small g. So we can rearrange this. So we can write like this. Small g is equals to gm upon r square. This one is the final equation, where g is the universal gravitational constant, capital M is a mass of the earth, capital R is a radius of the earth, and small g, which is acceleration due to gravity. Now the question is, what is the practical use of this relation between the gravitational constant and gravity? So practical use of this relation: designing the satellite and space missions Engineers used the gravitational constant to calculate the gravitational force between the celestial bodies. They use G and designing the launch vehicles and estimating the energy needed to escape the Earth's gravity. Second use, estimating the planetary properties. If we know the planet's surface gravity, small g, and its radius capital R, we can estimate its mass capital M. So, the formula for that is capital M is equals to g r square divided by capital G, where capital G is a gravitational constant and small g is a gravity. So this is all about the capital G and the small g, which is a gravitational constant and gravity. Thanks for watching.